Welcome students to my lecture number 39. Here we have discussed about the sprayers and the dusters and the nozzles, atomizers and various aspects earlier. Now here I would like to say and show to you that what we have designed at IIT Kharagpur, particularly from the knapsack type sprayers. You have seen that the knapsack type sprayer which are carried at the back, maybe manually operated lever, or it could be a small battery operated system motor where it can spray the liquid and all that, and type of nozzle which is used. We wanted to see if we can increase the output of the person. Here what he has to do is he has to carry the chemical about 15 liter for some at least 1 hour or so till the whole chemical is removed. So, even if 1 liter is carrying and moving inside this in the plant. So, we thought why not utilize the power of the man in a different form instead of carrying and then operating by one hand. It is very arduous, and maybe earlier I have in my lectures I have said that the consideration about human being or the operator is very important. And that is why you cannot have a device which does not match the required capabilities of the man. So, in order to have this system which matches the capability as well as which enhances the output of that man. So, we wanted to virtually transform a manually operated knapsack sprayer into a boom sprayer, and which can be simply carried inside the rows of the plants, and then spraying could be done. And we have slightly by ambitious project we took, and I will show you what we have achieved so far. See, manually operated one, as I said, here the pressure regulation is not there. Therefore, accurate and capacity applications are difficult to manage. This is what is written. Some sort of a justification is given for this, but then justification is very simple. In fact, when you talk of these, it is definitely difficult and arduous or not comfortable for the person to carry 15 liter and then keep on operating and then moving. Not only that, he keeps on operating by one left hand and maybe by right hand he is moving the nozzle, so that a particular swath is covered and then he moves forward. It is very strenuous task. If the same person is given a device which can be pushed inside or maybe pulled in the whole plant area and spreads onto that. So, we just employed this. For that we need to do certain changes in the design, because here the person is utilizing his hand left or right, whatever, depending upon whether he is a lefty person or a right hand person, he will do it. So, we have utilized 3-point linkage which is the crux of this particular design. What are the design considerations? Well, you can see here the different crops, medium height, I mean height of the crop should 10 to 80 centimeter, yeah, it varies depending on the crop, and different row spacing. Now, these are some of the agronomical requirements for a particular crop. Now, it should be easy to pull, simple in design, durable. These are the certain things which one would like to have. That from agronomical point of view, it must fit in the row to row spacing, and then the height of the plant. So, your design should be such that above the plant you are in a position to operate. Then physical and economic considerations. So, it should be low cost material. Well, these are all the minimum requirements that we think, and maintenance should be low, fine. Now, functional requirements. What is this? This is very important. We have, in fact, you have seen that we have hand operated which we call lever operated sprayer, so knapsack type. Now, the developed pressure should be in the range of this, because this is the one which we get about 1.1 to 1.5 kg per centimeter square is the pressure which we maintain in the knapsack type. So, we have to maintain that much pressure, and the nozzles which we have taken is 8 nozzles. In fact, as I told you that we are slightly ambitious and we wanted to have 8 nozzles spread boom, and that boom can be pulled. Once you are in a position to walk inside a crop, I think with the same power of the man we can do 8 times the work. This is what we thought, and we have been in a position to do this, but how do we achieve this part? This is one thing which is very important. So, what we did is that we have here used here, see, instead of the rotary action which is available from this rotor here has been converted into the reciprocating action, and for that we have used 3 point no the we have used linkage arrangement, I mean 4.4 bar linkage mechanism. So, just a second. Four bar linkage mechanism, this has been used. So, 4 bar linkage mechanism has been used here, and the rotary power which we have got from the operation and converted into the reciprocating motion of that which is done by the hand. So, you may say here that it will depend on the speed at which the person moves. Sure, it will depend on that, but then the pump remains same. So, we have used the same. You can see here that the tank which is here is the same tank which the person uses for his knapsack type. So, same pump has been used. What has been done is the operation which the man was doing by carrying it, it is being carried on a small frame which is made here, and then we have a handle here. So, the handle can be adjusted and the person can push this inside wherever he wants, and the rotary motion is converted into reciprocating motion of the movement of the lever, and we are maintaining a pressure between this to this. So, by using the 4 bar linkage mechanism, this has been achieved. So, the different parts. Now, these are some of the details of the one which we have done here. You can see here the chemical tank, about a 15 liter capacity. Of course, as I said that this is the one which is available already. So, we do not have to do anything. Then the main frame, a frame has been created, so that the frame has been so that we can keep the tank over there, and then this tank can be transported. So, for transportation of that tank, we have the wheel over here. So, the boom stand for creating the boom, because this boom should be maybe if you are talking of 8 nozzles. So, there is a spacing of the nozzles, and then it is not good to carry that width. So, we have made a in such a way that it can be folded, or maybe in this frame, so that it becomes in the same plane and it can be taken inside, and once you go inside the field you can spread it over. So, the frame has been created, and the boom length, total boom length is about 1800 millimeter. So, this length is worth to cover that much of swath, and in the earlier case swath was not possible. You have only one nozzle and the swath is not more than about 40-50 centimeters, or so 400 millimeters. At the same time, the person has to have all this thing carried on him. So, this is the beauty of this particular device, or what we are calling is knapsack-cum-boom sprayer, which we have developed at IIT Kharagpur, and it is worth showing you. This is good for small fields and good for small farmers, and also a cheaper device. Now, you can see here the sprocket which is shown with which we have made the rotary arrangement and converted to reciprocating arrangement, which has been shown. Well, you can see here the power transmission, the spray nozzle, the hose pipes. Some more details are given here. The power transmission system is chain and sprocket. Yes, while it is said that this chain and sprocket arrangement is there, we have to think of how this chain and sprocket arrangement can be made can be utilized for giving a constant pressure and constant rotation of movement of the lever, because this lever, when the person is operating with the hand, the similar aspect, similar effect has to be there in this case also, and we have been in a position to attempt that. There is a small stand also we have made, so that it, when it is there, it can stand on that, since it is only one wheel. That arrangement has been made. Then this particular handle, see, this handle has been designed ergonomically, so that the persons of different heights can be incorporated, because you will hold the handle here. So, you have to know what is the height of the person, what changes if a tall person is there, if a shorter person is there. So, accordingly there has to be change in the inclination of this handle. So, the handles, this handle can be changed, maybe that if I show you here, this is one location, it could be another location, could be something like this, maybe another location could be this. So, depending upon the requirement, these things can be changed. So, these can be changed, the handle can be changed here, the handle can be changed here. This is another thing which has been incorporated in this. So, from ergonomics and from human consideration point of view, we have considered several things. One is that we have reduced the fatigue or reduced the total load on the man which was carried at the back. Second, the person does not have to operate this and both the hands. So, you can see how much strenuous it is the task. We have removed that, and while in a standing posture, he can just push the liquid, push the tank which is there on a frame, and it is easier to push that through the system, because there is a wheel which is there. So, once it is on a wheel, it is easier to push, and the system will work, because power we have taken, the spray nozzle, see, spacing is 20 centimeter, and the spray nozzles are put at 20 centimeter apart. The output we are getting is this, at a pressure of 2.25 kg per centimeter square. So, this has been tested in fact, and we have found that the pressure, well, you might have certain questions. We have given an overlap of about 30% or so, as you can see from here, a certain percent of overlap is given here. Well, there could be questions as to what is the effectivity of this. We are testing this, and we have found very encouraging results. As you can see here, that you are getting 1.1 liter per minute at 2.25 kg per centimeter, slightly higher pressure, but then we are in a position to get this pressure. We can get this pressure at 20 centimeter spacing. So, and hose pipes are used, 15 millimeter diameter length, and length is 2000 millimeter, selected for mounting of the nozzles. So, well, these are details of how do you select these nozzles, how do you keep it. In fact, initial hiccups could be there when you are, this is the first prototype which has been, in fact it is laboratory prototype which we can say. So, we are working into more details of making it is a field prototype machine, and so that we can rigorous test it under the actual field conditions in different crops, and then get the. So, preliminary information which we have, we will like to show you. Well, this is what it is. You can have a look at this, that this is one diagram which is given for the AutoCAD diagram, and this is the actual unit here. Now, if I show you here laboratory testing, you can see, you have a look at this, that the person is simply pushing this, you can see, and from all the 4 here and all the 4 on this side, there is a discharge taking place. You may question that this discharge is reducing as it goes on that side. Yes, we have tested this, and we are trying to optimize the ones. Now, you can see that how much of area, see, about 1800 mm, so about 1.8 meter swath you can cover, and it is very easy for the person to cover this this thing. You can have a look at the second So, this is what the system which works. It is a laboratory model or a laboratory you can say yes, laboratory fabricated device which needs to be tested rigorously under laboratory as well as under this with the different nozzles. We have used a actually both several nozzles have been used in this case. You will see depending upon whether it is solid cone or hollow cone or fan spray nozzles, various things are there, but then each nozzle, each thing needs to be tested, and so these need to be tested. So, various things are required. For example, we need to test with the different types of nozzles, different spacings of the nozzles, and then the pressures what we are getting, and what is the speed at which we are getting that pressure, because and that will help us in operation of this, because the same tank, you can see the same tank has been used. So, you can say a slight innovation for small device, so small plots it can be used. The height can be elevated depending upon at what stage of the crop you are applying. So, this can be lifted. Now, some of the details of this actually, what are the details of this particular device and how much is the discharge that we get. We had tested under various conditions. Well, as I told you that maybe that from each nozzle, if you want a particular nozzle tested, then you will find here, just have a look at this, that the nozzles are here from 1 to 8, all the nozzles. Now, here you can see here that the discharge which we are getting here, the discharge is something like this. So, that means then we are not getting uniform discharge. So, our claim that we have virtually replaced what we are doing is not fully acceptable to the extent that well, there was only one nozzle, here there are 8 nozzles. But then if you maybe if you can check up, maybe somewhere this, you can say that this area could be said to be covered. So, maybe you can say here that this is the length that you are in a position to cover. You may not be in a position to cover, say, one here, gone. So, effectively you can say very comfortably that this is the area which can be covered with the discharge which we have got. Now, other thing which has not been mentioned here, I would like to tell you, is the speed at which the person moves. Now, there are certain problems when the person is there in the field, depending upon which crop. If you are talking of wider row crops, if you are talking of orchard crops where these are at certain distance, then it is easier for the person to carry this. But if you are talking of cereal crops where it is very difficult, then you have to consider what stage it is there and how much is the spacing between that crop, or maybe that we have to shorten the distance between the road to distance between the two wheels, the two transport wheels which are there and connected with the 4-bar linkage mechanism for designing the operation of the lever. So, this we need to look into this design and the crop, which crop we are talking for. So, there are certain aspects which need to be done. So, if we go back to the discharge values, so mean discharge, now you see here that there are various tests we did. So, you just have a look at these tests. Well, there is not a single mention of the speed at which it is meant, but if you say the speed of operation is about say 1.5 to 2 km per hour. So, depending upon 1.5 2 km per hour, then this information needs to be further investigated as to how much. Now, let us have a look at this data. See, test 1, what we are getting is say from nozzle 1 to nozzle 8, the variation is this. So, the variation is from the lowest you can say is about 119 and the highest is about 125. So, this is what you get, the fourth one you get 125, but this is 9. So, the last two are roughly you can say, as it is very clear from here, that they are not getting. So, maybe that if you can increase the pressure possibly you will get uniform. So, we are thinking that if you have maybe the speed can be increased, or the mechanism which has been developed, if that mechanism can be made efficient and made more robust, then we are in a position to get high discharge and at the same time high pressure. So, slightly higher pressure, maybe that this will be a flatter one here, and then we will be able to cover this, and the moment you can cover this, you have increased the capacity of the man. Same person with a one knapsack type, he is able to do this, and the same person when different device is given, he will be able to do this much. You can see another test. So, more or less each of the tests you can see this is the variation here, this is, and say another one, this is the variation here. Each of these from 122.8 to 124.4. Now, mean values, then I have T6, this is T7, these are all, but mind you, these are all tests which are at laboratory level. We are not talking of the field level at this point of time. So, the average that you get from N1 is about 120, and this is about 121 or so, and roughly you can get in the centers those. This is what I wanted to show you here. So, the mean discharge from each one of these milliliter per minute, you can get these values which we have got. So, although it appears that from each of the tests, mean discharge milliliter you get. So, I think this needs to be looked into for how many such he has got this. I think we may cancel this. This is the discharge which we can think of. So, the preliminary testing of this, the beauty of this device I can again emphasize is that we are employing the same person and increasing his capacity by the knowledge that you have about 4-bar linkage mechanism, which can be used for converting the rotary power to a reciprocating one and get this thing done. So, more and more testing of this unit is required under field conditions before we can say that yes, this machine is. The comparison between knapsack sprayer and developed manually operated knapsack-cum-boom. Now, what is the comparison? Well, it is worth comparing here, because as I said that the one in the knapsack type here, the ergonomic considerations, no ergonomic consideration has been thought of here, but then that is the first consideration which has to be done. The person, if the person is very comfortable in this operation, the person is not comfortable in that operation, but because both the hands are in action, he is walking, he is carrying that load. So, there is hardly any comparison so far as the comfort and safety of the person is concerned. So, apart from that, if you compare the other part of it, definitely we should be getting, because the speed, you can say that say the unit kilometer per hour, this is the speed of travel. Now, speed of travel is about 2.5 and 2.5. If we find out the same speed, I wonder whether we can achieve 2.5 or not, or maybe 3, depending upon the type of the and condition of the crop. If the crop is at a tender stage, maybe 3 weeks, 4 weeks or so, it is possible. But when the crop has gone more than 6 weeks, 8 weeks, and there we need to spray for control of pesticide, insect pests maybe throughout, then it is okay. Now, here the drawback one can think of is that since we are spreading everywhere, so we cannot control, it will come out at all locations, or we might have to plug these nozzles wherever we do not require, and it can cannot be used that way. We have to think of how it can be used for a spot location. So, in a spot, if you require, how do we do this part? So, that is one thing which is still a question mark for this particular device. And width of coverage, a meter here, the width of coverage is high. Yes, so we have a high width of coverage. Efficiency is better. Of course, efficiency in both the systems are more or less same. Hectare per hour, you can see you get a very high one. Then here 0.37, then operating time well 2.7 for say per hectare. This is very good. And time saving, what do you do in this time saving? In fact, is that 73% of the time you save. Yes, you save 73% of time, and what is not mentioned, as I said, is definitely the ergonomic considerations which the designer must think for such devices. And it will be a unit which is very good for small plots and small area, and the cost is also not very high. Yes, you will need to add the cost of the nozzles, the other setup which has been given. This cost will be addition to the cost of the device. You will have to purchase the tank which is there and use this. So, slightly cost will be higher, but then you can have a trade off between the total output and this. So, if we consider these, I think this is a promising device which will be tested, which is being tested at IIT Kharagpur, and we will be in a position to come out with a much better unit, field unit in future. Thank you very much for this, and if you have any other questions and then queries, we are most welcome. Thank you.